Kiwi Dale, and I am going to be your tour guide of the famous periodic table of elements. An introduction of this is a Russian chemist, Dmitry Mendeleev, discovered a pattern in 1869. He wrote names and properties of the elements on the cards. Pretend those are cards. Okay. Then he arranged them in order by increasing the atomic mass. And the atomic mass is the little bottom number. He noticed a pattern. He noticed that the element properties repeated every 7 elements. But a few of the elements' properties didn't fit his table. He thought that more accurate atomic masses would fix the gaps and flaws in his table. So then, in 1914, a British scientist named Henry Moseley determined the number of protons, which is that top number right there. All the elements fit the pattern when they were arranged by the atomic number. Each square includes the element name, which would be hydrogen or lithium, a chemical symbol, which is the letter, which is H, Li, the atomic number, which is 3, or 1, which is a number of protons, and the mass. Yes, okay. Let's separate these into, okay, these, the horizontal ones, going this way, are called periods. Like, it's 1 period, it's 2, 3, 4, 5, and it keeps going. Okay, and then these are called groups or families, and they all share similar properties. Okay, these two, they are a part of the periodic table, but they are brought down to make it narrower. And this top row is called lanthanides, and those are called actinides. And, okay, let's start off with the alkali metals. Alkali metals are this first group right here, and they are all metals, and they have 1 electron on the outer energy level, and they are all very reactive with, just very reactive. They're very soft, and their color of silver, and they have a low density. Okay, then in group 2 you have the alkaline earth metals, which have 2 electrons in the outer energy level, and they're really reactive too, but not as reactive as the alkali metals. They have a color of silver, and they have higher densities than the alkaline metals. Okay, then groups 3 through 12, which is on here, it's numbered different, but it's between these two. 3 through 12, those are called the transition metals, and they either have 1 or 2 electrons in an outer energy level. They are less reactive than the alkaline earth metals, which is those. They are shiny, and they're good conductors of thermal energy and electric currents, and they have higher densities than those 2 groups, except for mercury. Okay, then you have the boron group, which is group 13, which is right here. It contains 1 metalloid and 5 metals, and how you know is there is a zigzag line that goes right here, and it goes all the way down to right here, like right through there, and it tells you that on the right side is non-metals and on the left side is metals. And so in that group there's a mixture, and in this boron group it has 3 electrons in the outer level, and it's very reactive, and they're all solid at room temperature. That's why they're put in the same group. And on the zigzag line, the pretend one, which is boron, silicon, arsenic, germanium, antimony, tellurium, polarium, and acetine. They are all metalloids, by the way. Okay, then you have the carbon group, which is group 14, which is right here. It says carbon. It contains one nonmetal, 2 metalloids, and 3 metals. It has 4 electrons in the outer energy level, and the reactivity, which is like how it reacts, it varies among the elements. So like this one could be different than that one. And it's a solid, and they're all solid at room temperature. And if you notice, like the number of outer electron levels is the same number, like the last digit in the group, which is pretty cool. Okay, group 15, it has 5 electrons in the outer level. It has 2 nonmetals, 2 metalloids, and 2 metals. Okay, this group also varies among the elements whenever it's like reactivity. All these are solid at room temperature except for nitrogen. And also, if you notice, never mind. Okay, the oxygen group in group 16, it has 3 nonmetals, 1 metalloid, and 1 metal, which is that group right here. It has 6 electrons in the outer level. All those are very reactive, and all of them but oxygen are solid at room temperature. Okay, group 17, this group right here. All those are nonmetals. They all have 7 electrons in the outer level. All of those are very reactive, and they are poor conductors of electric currents, and there are violent reactions with alkali metals to form salts, but they're never in uncombined form in nature. Okay, the last group, which is group 18, all those are nonmetals. All the electrons in the outer level are 8, except for helium, which only has 2, because it's special. All these are very unreactive, and they're all colorless, odorless gases at room temperature. Hydrogen is one by itself, because it only has 1 level in the outer level, like 1 electron in the outer level, and it's very reactive, and it's colorless, odorless at gas room temperature. It has a low density and explosive reactions with oxygen. And then this is the same periodic table, but all these circle ones that I circled, which is that one, 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 are all gases. Bromine, mercury, all those are liquids, or both those are liquids. The ones with the lines going across them like this are nonmetals, and you can see that they're on this side. The shaded ones is the zigzag line, which is the metalloids. All those are metals. Then this is the noble gases.
And that is the periodic table of elements.
Thank you, Dimitri, for creating that.